my name is Gregory Touretsky. I'm the product manager responsible for CORTX and Lyve Rack offering. And we'll cover today basically where we are with CORTX, why we are doing it, what we are doing, and what our plans are for the future. My focus here will be mainly on the CORTX and different use cases and where it is used today. If you're interested in Lyve Rack in particular, please reach out to me with Twitter or email, and we can have a separate conversation about the Lyve Rack. But the focus here is really on where we are with CORTX and what the plans are, even though I'm going to cover Lyve Rack as well at some level. Okay, thank you for your time and thank you for joining us. We are excited to see so much interest from all over the world in this product. So I'll start from why we are doing this, why Seagate helps to launch this community and work on CORTX and various implementations of CORTX. One thing that we see, and I'm sure everybody is aware of this, is the amount of data that people are generating is growing extensively. And we see data generated by individuals, we see data generated by enterprises, we see a lot of data generated by devices. And the actual numbers vary. This is a forecast coming from IDC that talks about 175 zettabytes that will be generated worldwide by 2025. However, if we look on this chart, it also shows another interesting indicator. And it says that out of this data, only about 10% will be stored, about 17 zettabytes will be stored. The 90% will not be stored. And we see this as a lost opportunity to get additional insights and get additional information that could help the humanity to reach out to the new heights. And so we try to analyze why the vast majority of the generated data is not stored, right? We also look into what some of the hyperscalers are telling us. Right? This is a nice quote from Peter Norvig from Google. He mentioned that very openly that whatever decisions they make, whatever applications they develop, and they do great things, they can do that not because they have better algorithms than others. They just have more data, and that helps them to make better decisions. What we see with the enterprises, right? They have to make those compromises all the time when they want to store more data and get more value out of this data, but this increases the cost. Right, they have to pay more for storing this data, the infrastructure, whether it's CAPEX, when they deploy storage systems on premises, whether it's OPEX with public cloud or on premises as a service solutions. They have to pay to the IT personnel to support all this infrastructure and so on. And in some cases, in many cases, they actually decide to cut this cost at some point, and instead of storing more data, they decide to throw it away, and so it limits them eventually in getting various insights and improving the business. Another thing that we see is we work a lot, Seagate, with the hyperscaler companies, the Amazons of the world, the Googles, the Microsofts, and we see that they definitely can move very quickly and adopt new technologies very quickly. Right? They own the entire stack, from hardware to applications to operating system and so on, everything that works within the hyperscaler data center. It allows them to respond quickly to new innovation in hardware. For example, whenever Seagate, as a hard drive provider, comes with the new solutions, they can jump quickly and adopt those. They can go and use the highest capacity storage devices that we produce. This is great from the Seagate perspective. It helps them to offer the best price per gigabyte, because the bigger the drives they use, the better economies of scale they get, and the lower price per gigabyte can be offered. This is another interesting slide from IDC that shows a mix of HDDs and SSDs that the major hyperscalers are using. We're not talking about the actual names of the hyperscalers here. It doesn't really matter. What is important is that all of them, they have massive amounts of storage. The vast majority of this storage is on the mass capacity spinning drives. And only somewhere about 10% in average is used with the SSD drive. So what we see is to store this massive amount of data, they keep going with the large HDDs, and we would like to help the enterprises to do the same. This is another interesting chart here that shows cost per petabyte of storage or terabyte or gigabyte as you go with bigger drives. So again, the bigger the drive that you use, the lower cost per gigabyte you have to pay. And with this ability to innovate and introduce new technologies at hyperscalers, they can jump on the latest drives sooner than others, and they can drive the cost down significantly. So it puts the enterprise in a less favorable position. They have to, they adopt new technology at a lower speed because they have to leverage solutions coming from the ISVs. They may not be able to support those latest drives soon enough. And again, this gap in price that the enterprise have to pay if they deploy stuff on premises, as opposed to going to the public cloud, becomes wider. So we wanted to see how we can help and drive the enterprise to adopt those latest technologies and latest drives sooner than it usually happens today, and what would allow them to go and store more data and instead of storing it out. So another thing that we looked at is the vast majority of this generated data is the unstructured data, and most of the unstructured data today goes into the object stores. When we look into the offerings that are out there on the market today, there are kind of, we define like two types of object storage, if you wish. The one is what we define as the mass capacity storage, and this is today probably about 90% of the object storage capacity that is out there. The focus here is really generating and storing a lot of data, and the focus is on the cost per gigabyte. When you're talking about some customers who generate petabytes of data a month and maybe even more, they need to be able to get an affordable capacity to store this data and process it. They definitely need performance, but they usually do not require maybe very low latency, and this is where most of the data goes. So the main focus for them is cost per gigabyte. There is also a growing segment for the high performance object stores where people are trying to get insights of the data and where the latency is very important. Those are this relatively small segment that is willing to pay a premium for the object storage. And one example that I use here is from the Azure Premium Blob Storage, something that they announced, I think, last year as a generally available service. They charge $150 per terabyte per month, and they apparently have customers for this service, but it's hard to say how many of those customers are out there. In any case, from our perspective, when we looked into different ways to address this need for customers to store capacity, and with our focus on this mass capacity drives, we are clearly focused with CORTX and what we're doing with Lyve Rack, especially on this mass capacity market. We plan to address demand from customers who are looking for multi-petabyte deployments going to exabyte scale and beyond. Okay, so those were the considerations that we had to look into when we thought about CORTX and what could we do with this platform. So where are we today? First of all, we announced CORTX, that was about 3-4 months ago in September. If you haven't seen that, this is an S3 compatible object storage platform. It is available on GitHub today, and it's 100% open source. We are welcome everyone to join the community and participate. I assume if you are on this call today, you are already involved in one way or the other, and this is great. We are excited to have you on board, and we would love to hear more from you on what you do with CORTX, and if you can bring your more friends or contacts to this community, that will be great. We realize that not everybody might be interested in building CORTX from the source code, so we provide also a virtual machine that can be downloaded from GitHub and deployed within 10 to 15 minutes on a variety of hypervisors. It takes something like 10 to 15 minutes to deploy a VM and launch it, and you can get a preview of the functionality of CORTX. It's not intended for production use, but we've seen people using it for development, for testing, validating their software with CORTX, and so on. And we have this great growing community that offers support for CORTX. Again, welcome and join the team. What can you do today with CORTX? So CORTX, unlike some other open source object storage solutions that are available out there, we are trying to provide a solution that can be easily used by an enterprise. So it is not just a building block that provides only S3 functionality, for example. We are looking into the manageability aspects as well. One thing that we offer is the management interface for CORTX with the API, CLI, and GUI. So when you install CORTX, you can get this user interface for cluster management and see performance, provision users, and so on. We provide the API that is S3 compatible. This is a current set of APIs that we support. We plan to add more API support as we evolve. But we support today the S3 APIs that are listed on this page. We support a subset of IAM APIs for user management. And then we also provide the CSM, what we call the CSM API, that are used for the cluster management itself. CORTX is a multi-tenant object storage offering in a way that you may define multiple tenants. We call those tenants S3 accounts within the cluster, and for every account you may define IAM users that can be used to basically access the data, and you can have multiple buckets within every account. By default, every IAM user within the account can access all the buckets and objects within this account, but we also allow to set bucket policies and access control lists to provide more granular controls over what those users can do. We also provide management users for the cluster itself. There are different roles that we support, the super user, the manager, and the monitor accounts that can be used by the IT administrators who want to deploy and manage CORTX without accessing the actual data. So those accounts are used to configure CORTX environment. I mentioned bucket policies, and we support bucket policies today compatible with AWS. You can use it. It's a very powerful mechanism to define who is allowed to do what or is not allowed to do what on the bucket. We support also access control lists in CORTX, so you can, it's more kind of a legacy access control mechanism, but you can set ACLs for both objects and buckets, and you can use a combination of bucket policies and ACLs if your application requires that. From the CORTX perspective, it's all fully supported. One other thing that I wanted to bring up here is the key component for CORTX, and there was a deep dive session, I think a couple of months ago in this forum. If you haven't attended that, there is a recording available, and I would highly recommend to go and listen to Nikita's talk there, covering Motor. If you have not attended that session, Motor is basically the heart of CORTX. This is the software that we use to store the data, to get data protection, data placement across the actual LANs that we use within that we provide from the storage perspective. Motor is designed to provide ultimate scalability from both a horizontal perspective. You can grow the system by adding more nodes, and it can be handled by Motor. And it can also scale vertically. So if we offer more memory and CPU on the nodes, you can get more scale as well. There is a lot of thought put into the design to ensure that it's fault tolerant. We provide the Erasure coding capabilities. There is a lot of focus on the observability. And there is a component in Motor called ADDB that allows to collect data about performance and behavior of the system as a whole. And it provides very powerful instrumentation to really analyze the status of the system and where we are at every point in time, and decide what kind of performance tuning might be required. So this is a very powerful tool. If you haven't looked into this, please do. It's very extensible. We can use it to add additional capabilities into Motor, and there are some interesting developments around the space, especially in the research community, which I'll talk about later on today. And we are working to make it available on any Linux distribution that we want to use. Even though from the CORTX perspective, our main focus today is on CentOS. So if we look on the CORTX node, right, and we have different implementations of CORTX with different sets of nodes, but if I'm looking on this from 30,000 feet, we are running the OS, and our development is focused on CentOS today. We deploy CORTX itself. We also leverage a variety of other open source products that we require for various purposes. For example, we use the messaging queue. We use OpenLDAP for accounts management. We use other services to ensure availability of those components, and so on. And every node in CORTX has 3 network interfaces today. We use separate networks for management and data access. Those are public networks. We also have a private network that is used for inter-cluster communication. Basically, it's a Motor network and the communication network for all the other distributed applications that we are leveraging. So we expose particular ports to customers for access. We block all other ports from the security purposes, and this is how this node looks like for the customer. If I zoom in a little bit more into what we have within the CORTX system, we have multiple components. Some of them are available and they can be used with any hardware. Some of them are more focused on support for Seagate storage in particular. Some of those key aspects here, as I mentioned, there are 3 networks that we have. We are providing what we call the CSM, the Component Service Management. This is basically all our management stack with the GUI and that we provide. We have this Seagate specific library that we call SSPL. It's not required, but this is the management interface that we develop for specifically managing the Seagate enclosures, Seagate drive. So this will provide the best solution for you if you're going with the Seagate storage, but again, it can be used with other storage systems as well. Maybe some functionality will not be available and can be provided by the open source community. There are other components. Definitely the Motor is the important part. As I mentioned, we are running several instances of Motor on every node. They provide the IO services and also the KV store that we use to within the cluster. And we have the S3 server instances running on every node as well to provide the external S3 access, and then they communicate with Motor at the back end as a way to protect and store the data. So this was quick coverage of the internals for CORTX. Again, there are separate deep dive discussions. We had some of them already on Motor and S3. There are more plans for the future that we'll cover later. So please stay tuned and also listen to the recordings of the previous sessions if you haven't done so before. What do we see today and where CORTX is used. Right. First of all, CORTX has a long history within the research community, especially in the European Union. We have a dedicated team that works with the research projects. One of those projects is what is called SAGE, and now it's in a second iteration of this project called SAGE 2, or Storage for Exascale Data-Centric Computing. They are focused on the research around the unified data storage platform for various large-scale workloads, AI, big data, HPC, and so on. And the CORTX and Water in particular is the key element for this research. They are developing an interesting use case where CORTX is used actually in a multi-tiered environment with multiple tiers of storage. They have the NVRAM, the SSDs, and spinning drives in this cluster. This is a 22-node motor cluster deployed in a supercomputer center in Germany with, again, different tiers with different types of memory. They have a combination of Intel architecture and ARM nodes, and it is used for various interesting use cases. There are multiple PLCs that are executed there, including the quality of service work and some experience running CORTX with 3D Crosspoint and other environments. So we are excited to be part of this project, and it's giving us a lot of insights into what CORTX could do in different interesting use cases. There is also another thing that Seagate in particularly is investing in a lot of focus is giving a reference architecture, how CORTX could be used at an enterprise, right? If you remember the slide that I started with, from the Seagate point of view, we want to enable an enterprise to go and adapt and start using the latest generation of hard drives and latest generation of our solutions as soon as it becomes available at the same time when hyperscalers start using those. So we are building this reference architecture that includes a particular hardware with the Seagate drives and Seagate enclosures and servers. We invest in testing these systems and offering them with the best user experience. And all this is what we call a Lyve Rack. And the Lyve Rack experience, we are making it available through selected partners. So if you are interested in this offering, please reach out to me later on or talk to your Seagate contacts, and they'll be glad to share with you more information about Lyve Rack availability. We launched this first implementation of Lyve Rack for edge customers, those who are interested in a relatively small scale deployments. By small scale here, I'm talking about 1 petabyte of usable capacity. So it may not look really small for an SMB, but we definitely see interest from many companies into this kind of with this kind of solution. With Lyve Rack R1, we are providing today a single what we call RBOD, single smart enclosure with 84 drives and 2 1U servers that are running CentOS and CORTX. Again, similar to this picture that I showed earlier today. This is essentially an appliance with about 1 petabyte of usable space, and we see initial interest from the customers who are buying those systems and providing some feedback. It is definitely the very first step for us. We plan to go and develop new architectures around the Lyve Rack and CORTX. I'm going to cover this in our plans, but this is our first step, and we're excited to see this going to the market. Where are we going to with all this? We talked about CORTX today in the SAGE and SAGE 2 projects. We launched Lyve Rack R1 in December and started to ship it. Those are definitely the first steps at this journey that we expect. First of all, on the research side, we continue to be involved in multiple research projects. I think it might be actually a great topic for one of the future meetings to bring some of the folks from our team to talk more about CORTX and research community. But those are just some of the projects that I listed here where we are involved now with CORTX. One of those is the project called Maestro, and there is a lot of focus on the data-aware middleware for very large-scale applications. It's a joint work with many participants, and the motor is a key item of this project. There are other projects as well around the weather simulations and climate simulations. This is great to see how CORTX can help people to really get better understanding of the climate evolution. So another exciting project there. Involvement around the data management platforms, research that we do with a university in Mainz around the deduplication for CORTX. And there are a few others that I didn't even list on the slide. Again, I think we should have a separate talk covering the research projects. We are also interested in engagement with other universities. If you can think about some interesting research program that you would like to do with the object storage platform, reach out to us and we'll be glad to see how we can help with that. From the enterprise point of view, we are looking into the future as the way to offer what we call the perpetual storage platform. We also call it the Lyve Rack R2, a second generation for Lyve Rack, more going into this large-scale, scale-out implementations. We do not see this as a single project. It's going to be an evolving product that will get more features and functionality as we expect more feedback from the community and the customers. And the focus here is really to provide this scalable, clustered, S3-compatible object storage for the on-premises customers. We are looking into some aspects of the cluster and what challenges people usually have today when they deploy object storage systems in general and object storage systems in particular. One of the challenges that we see is an ability to keep a cluster running for a long time without requiring data migration from an older generation to a new generation of hardware. So this is one of the things that we are looking into the design for CORTX and the Lyve Rack in particular, is the ability to offer this renewable cluster when different individual components of the cluster can be replaced over time and provide new generations of hardware without service interruption for customers and without the requirement to take down the system for data migration. We are focused on the ease of use for customers. We want to make sure that whoever deploys the system does not have to go through the extensive training. The system can be operated and it can be deployed and go to operation very quickly. We are focused on the scalability, going into multi-petabyte and exabyte scale with this solution. And there is a lot of focus on the reliability and the upgradability of the solution as well. Those are kind of key building codes that the development team is looking at when they make decisions about the architecture of CORTX to ensure that we can really provide a solution that can give all those capabilities to the customers. Those are some of the ideas that we are looking into when we are designing the Lyve Rack R2 and CORTX to support that. We are looking into particular implementation. Again, it does not require Seagate storage from the CORTX perspective, but when we are looking into the reference implementation that we call Lyve Rack, we obviously designed this with Seagate enclosures and drives in mind. So an individual node, as we define this, is basically a smart enclosure and the server running the operating system and CORTX software. We are defining a new construct here that we call a smart storage set. This is basically a smallest building block for the cluster. It will include X nodes, then we are still defining what those numbers are. Stay tuned for the future announcements about CORTX and Lyve Rack. Within a storage set will require the identical hardware, but different storage sets may support different types of hardware. this will allow us to offer this renewable cluster concept and allow us to go into the newer generations of hardware over time. And then we have this next level, which we call a cluster. It's basically an instance of a CORTX or Lyve Rack R2 cluster. It should consist of one or more storage sets. And again, hardware within a single storage set will be identical. Hardware between storage sets may vary. And we can use that to provide different generations of hardware within the cluster. For enterprise customers, it's important to get a support behind the offering. So those who are willing to go with the enterprise Lyve Rack version, we are going to provide support as well. And it will be offered at the storage set level. So if a customer is going to deploy a cluster, he may add more storage sets over time and get support extended based on the storage set that were added. And we are focusing on support for graceful addition or removal of the storage sets from a cluster, again, to provide this uninterrupted service to customers as the cluster keeps running. So we are looking not only on the day one on the deployment, but also on the day two operations and how this cluster can be used in production. One of the big focus areas for us is data protection. This is the most important thing, right? We can't afford any data integrity issues in a storage system. Obviously, that's the largest focus area for us. One thing that we see in majority of the object storage systems today on the market, they leverage a single level erasure coding. Right? You may take a bunch of JBODs, put them or local drives, connect them to servers and build a cluster, and then you get data protection through replication or erasure coding using those drives. So whenever the drive fails, there is a rebuild process that starts. The bigger the drive, the longer this process takes. It generates more noise in the cluster network. It provides more overhead on the nodes in the cluster. And the bigger the drives, the longer the rebuild time it takes, and the more exposed your storage becomes for additional drives failure and even maybe to the data loss. This is not something that we want to get into in large-scale CORTX deployments. We had a lot of theoretical discussions about how it could be addressed, and there was a great talk last month by Sergey from Seagate about different applications and decisions that we're making to provide the best data protection. So this is what we expect with the scale-out CORTX implementations and Lyve Rack in particular, is support for hierarchical erasure coding. We are focused on the smart enclosures, the RBODs, such as Seagate 5U84 and the future products around this technology that can provide the data protection within the enclosure as a first step. So every enclosure here has its own erasure coding within it using Seagate Adapt technology. This allows us to ensure that any drive failure is handled within the enclosure. There is no implication on the cluster network. There is no implication on servers, no performance overhead. Any drive failure is handled within the enclosure. And we have a lot of logic within what we call the Adapt data protection layer to ensure that even for the largest drives, the rebuild time will be minimal, and we get back into the protected state very quickly. So we assume that over 90% of all drive failures will be handled within the enclosure without any need to provide without any overhead on the cluster. There still might be cases when the entire enclosure would go down, and this is highly unlikely because every enclosure is highly redundant. Everything is every component there is redundant. whether it's controllers and power supplies and so on. But still, an enclosure may go down. So this is why we are adding a second layer of Erasure coding within CORTX itself that will ensure that even if the entire enclosure is down, we still can serve the data for both reads and writes. One thing that we are receiving in this case is that the enclosure, when it's going down, is not lost forever. It might be that there is some failure of a component and was taken down for service, or maybe there's some upgrade going on, and then enclosures may go up and down. So in case of the enclosure downtime, we do not start to rebuild automatically. The assumption is that it will come back soon enough, and then it will rejoin the cluster. It will keep the data that was there, will replay whatever needs to be updated while this enclosure was down, maybe rebuilding some metadata and so on. But we do not plan to do rebuild in case of the enclosure is down automatically. Now, in the very unlikely situation that the entire enclosure got lost completely, then we can initiate the rebuild as well. And again, this second level of data protection would allow us to recover the data, even in the case of the total loss of an enclosure. Just to emphasize it here, every enclosure is about a petabyte of usable space. So this is something that we are handling within CORTX data protection. So this is how we expect at a high level this future architecture to look like with the new generation of CORTX and what we call the Lyve Rack R2, basically building a scale-out cluster with multiple nodes. We talked about this architecture and what those nodes are, individual servers running OS and CORTX with the direct attached smart enclosure behind it. We are going to offer a set of recommendations for the particular hardware, best listed hardware for the switches, but again, we should work with any standard switches as well for the private network, and we're going to connect to the customer network for both data and management. We are going to support different smart enclosures behind this cluster, including the 84 drives and also 106 drives, so we get very high density and can deploy large capacity clusters at the most dense setup in the data center. So less floor space, less things to fail, and so on. So I'll stop here. I think this is the material I wanted to cover. I'd be glad to hear from you if you're already involved in CORTX, what your thoughts are, what do you plan to do with this. Is there any other questions from you on where we are, where we're going? I'll be glad to take them now.
If anybody wants to just jump in the chat and say that they want to ask a question, I can see about unmuting. We did have a question. What kind of ecosystems will the CORTX need to be integrated in as part of enterprise deployments, e.g. ITSM for overall management, data movers to hyperscalers, virtualized or container ecosystems, etc.?
Sure. So we are working on the ecosystem integration. There are several things that are already in flight. First of all, if you go to a GitHub page that lists CORTX integrations today, we have several of them listed there. We, for example, we set up CORTX with Splunk. All right, so Splunk supports this smart store feature functionality when the data from Splunk can be offloaded to an object store. So we have tested that, and you can find this how to configure Splunk with CORTX on GitHub. There are other examples of what was contributed as part of the hackathon. This is another interesting thing that we are doing with CORTX. We plan to run multiple hackathons, as we did already once last year, and there are more coming, where we invite anyone to participate and help with integrations and other cool things around CORTX. So stay tuned with that. During the last hackathon, we got some integrations around the TensorFlow and the image processing and other things. All those integrations are listed on the GitHub page. From the Lyve Rack in particular and CORTX in general, we're also working with some enterprise partners on testing And as we are going to complete some of those certifications, we'll publish them, so stay tuned. But definitely there is a lot of focus on that.
As CORTX is CentOS based, going forward, CentOS Linux will be converting to CentOS Stream any plans of dealing with it. Continue with CentOS or move to Fedora or RHEL?
Yeah, so there are many interesting things that are happening in the industry right now that we are looking at. So CentOS decision is one of those. There are some other aspects, right, when we're dealing with the open source right now, and Elasticsearch, for example, with all the license changes. It's another interesting challenge for us, and we have to make various decisions in the long term. What do we do about the license changes there? On CentOS in particular, we are staying with CentOS for now. The common versions are going to stay around CentOS 7.9. which still has support till 2024. We are looking for alternatives. We definitely need to make a decision what do we do in the long term, but for now we are still staying on CentOS.
Do we have some size examples of CORTX in production, largest cluster size?
So we do not have public customers yet. We hope that we'll have some announcements later on. We also plan to have a DataSphere event later on this year where we may have some customers coming and talking about their experience. I can say from the industry verticals point of view, we have deployments with cloud providers. We have deployments with automotive customers. We have experience working with some defense and federal customers. So there's a lot of initial interest around this.
So you have open sourced a scalable rebuild oriented erasure already, and you plan to open source a scalable rebuild multi-tier erasure. Can you comment on the erasure? Does it use ISAL or other dependencies?
So we are switching right now to this. There is more work happening within the community, so I suggest you to join the discussion with the development team, and they can share more about this. The particular libraries that we are using for the Erasure coding.
John Bent adds that we're currently using libgalloy from Planck, indeed switching to ISAL.
Exactly.
Someone wants to know about K8 plans?
So with Kubernetes, we are definitely interested in, there are two things that we can talk about Kubernetes. One is an ability to store data from a Kubernetes, from an application running Kubernetes into the object storage, and that definitely works. So we provide S3 API, and if you have an application running in Kubernetes, it can communicate with this S3 API the same way as it can communicate with any other object storage. You can store credentials as the secret in Kubernetes and so on. There is another aspect of an ability to use Kubernetes to run CORTX itself. We are interested in offering this as part of the open source work that we are doing. There are some concerns around it, right? We believe that the best experience the customers may get is by using the particular hardware with the Seagate enclosures. When you run an application in a storage system that runs in Kubernetes, it is usually the particular storage is fully abstracted. So we can support Seagate storage, but we won't be able to expose the features of the Seagate storage to the application, because again, we'll have to go through the Kubernetes abstraction layers of persistent volumes and so on. So we're still looking into the ways how we can do this in the best way. There are also some changes in the software itself that we must provide. For example, we are working now to remove some kernel dependencies that we have in CORTX, and the next generation will not have those dependencies. So both things are being under discussion right now. Once we understand better how to do this, we definitely plan to offer a Kubernetes-based CORTX implementation.
Do we trust Intel to keep ISA healthy in open source?
So this is something that, again, we see that this library is used by many community partners. We are doing assessments about the decisions whether this library is the right one right now. As John mentioned, we are switching. We definitely plan to switch from what we use today. And so far, we believe that the Intel library is the best direction to go. We also work closely with Intel on various aspects. There are many interesting projects that we work around CORTX and Deos, for example, with Intel. So it's a good relationship and good connection there.
How will Intel Deos be integrated into the CORTX architecture? Do you just add NVMEs into nodes and run the library?
Hey, Gregory, you want to take this one, or I can take this one as well?
Yeah, you can go ahead, John.
Yeah, so that's a question from Ryan Tyler. Thank you, Ryan. We're looking at that. We've got a whole bunch of different proposals, and so we've got a meeting coming up with the Intel Deos team. We have a weekly meeting with them. We're working on this Intel Deos integration. Some of that is actually, all of that is intended to be public, and so a lot of that can be seen in our CORTX experiments directory. People can repository. But basically, yeah, there's a whole bunch of different ways that we're thinking about doing it. One of them would be Deos as like an HSM tier in front of CORTX. Another, and that would be sort of like the simplest, least in-depth integration, sort of like the most superficial integration. Just put them both together in your data center and put some file tiering HSM type software in place. But we're also looking at much deeper integrations, such as at our S3 layer today, as was described in our second monthly Meet an Architect webinar. Basically our S3 layer just sits on top of our motor layer and translates S3 namespace into motor key value and motor object operation. Well, the motor API is very similar to the Deos API. So we could essentially do HSM type functionality or layout decision-making in our S3 layer. So we've got a presentation that we're going to be going over with the Intel team next week in our own little private meeting. But it sounds like there's interest from the community. So, we'll happily publish, sort of those design decisions that we're talking about with them out to the community as well. Yeah, hey, Gregory, are we going to continue with the cluster IP using IP tables? It would be nice to get off multipath.
Yeah, we are not going to use cluster IP in future generations.
There are just a couple of questions. I don't know if we have time, but are we going to continue with cluster IP using IP tables? It would be nice to get off multipath.
Okay, so I think there are a few different things in this question, and I already answered that. We're not going to we're not going to use cluster IP in the future generations. From the multipath perspective, it really depends on the setup, right? With the particular setup with the Seagate enclosures, multipath is essential for availability. If we lose one connection, we still want the cluster to be operational. Other types of deployments may not require multipath. Depends on depends on the use case and the implementation of CORTX.
Awesome. Okay, well, I think that's all that we have time for. Thank you for putting it forward. Our last slide, I'll talk a bit about this. I'm so glad everybody was able to join us today. We have a couple of links. Obviously, you can't click on them, but they should be easy to remember. You can go directly to our GitHub, the CORTX GitHub, through the first link. That's cortex.link/GitHub. You can also join our newsletter if you're not already on the monthly newsletter, but I imagine most of you are. It's at cortex.link/newsletter. And if you would like a laptop sticker, we have them. So please go to cortex.link/stickers if you would like a sticker. So thank you so much for joining us. And we will be back next month with another one of these sessions. So I hope to see you then.